Okay, if not, I'd like to introduce our next speaker, Professor Tim Benton from Leeds University. And Tim's going to talk about organic farming and biodiversity at different spatial scales in the landscape and the interaction between those.
Thank you very much to Michael for doing all of my introduction to me, for me, so I can skip through. I can't say strongly enough that we are, as Michael was saying, in a kind of period of crisis over the next 20 or 30 years. And it's very well summed up in this diagram, which is due to John Beddington, who's the UK's chief government scientist. And he calls the future the perfect storm, because we've got coming together the drivers of climate change, changing things radically. We need more energy per capita. We need more food per capita, and we need more water per capita. And how can we arrange for all of that demand to be met whilst the world is changing very fast due to climate change, and whilst we can do it sustainably? So, as Michael has said, a lot of what we are thinking about in terms of how we manage agriculture sustainably comes down to how we provide ecosystem services, because ecosystem services have an economic value and can be valued, and by valuing ecosystem services, we're then in a situation to say, yes, we get this much out of ecosystem services, so it's therefore worth us investing this much to make sure that we maintain them. And as Michael has said, there's a whole range of different ecosystem services that are provided, some of which are to do with pollination, some of which are to do with pest control, soil fertility, water, and so on. And what I'm going to do now, and I know, and several people have said to me that when they look at my PowerPoint presentation, it's full of numbers and graphs and things like that. What I want to do is just talk through some of the kind of ecological science that underlies this. And I'm not going to go into any of the details on this, but the graphs in there and some of the references in there show you that what I'm going to be talking about is supported by data. And I think that's important in a world of politics and spin, to understand that there is real data underlying these things. So there are two big questions that I'm going to talk about to do with ecosystem services and farmland. And one is, if you're managing land and that land has multiple uses, is it better to manage the land in terms of having areas that are used for agriculture on one hand and biodiversity on the other hand? Or is it better to manage agriculture and biodiversity on the same land across the landscape? So that is known as land sparing, where you set aside land and manage it for biodiversity, or land sharing, where you try and farm extensively throughout the landscape. So there is a very important paper that Michael already referred to in one of his slides by Rhys Green and other people in Science in 2005. And what they effectively said is, if you have a graph like this, where you have biodiversity on the vertical and yield on the horizontal, if by reducing your yield a little bit, if you gain a great amount in terms of biodiversity, then actually sharing the landscape becomes profitable, because you're getting both high yields or moderately high yields and high biodiversity. If, on the other hand, you have a graph like this one, what that suggests is that to increase your biodiversity, you have to reduce yield so much that effectively you're abolishing the high productivity to gain your biodiversity. And in a situation like that, it is better to set aside land and manage it specifically for biodiversity, and then use the rest of the land specifically for production. So this is a kind of Henry Ford idea that you get the most by specialization rather than trying to do everything in the same place at the same time. So that's the first question I'm going to deal with. The second question is perhaps the most important, I think, in terms of the way that we think about agriculture, and that is, what is the right scale at which to manage the land to provide biodiversity or ecosystem services? Should we be managing every field? Should we be managing every farm? Should we be managing a landscape, so a valley or a 10 by 10 square or a county? Or should we be managing a country, a region within a country, or should we be managing the world? And actually, all of those things have different consequences. And so deciding what level you want to manage at makes a really big difference. So I'm going to talk about the results of a study that we've been publishing quite a few papers on over the last 6 months or so, and I'm not going to give you any details of this. We can talk over coffee, or I can show you reprints and so on. But basically what we did was that we spent best part of 2 years picking farms that were similar in every aspect that we could manage. They were similar in size, they were similar in enterprise, they were similar in distance to towns, they were similar in 30-odd environmental variables: soil, slope, altitude, etc., etc., etc. The only things that differed were some were organic farms and some were conventional farms, so we could compare directly, like for like, field for field, crop for crop, what happens on organic versus conventional farms. And some of them were in landscapes that had lots of organic farms, and some of them were in landscapes that had little organic farms. And we call the landscapes with lots of organic farms hotspots, because they should be good for biodiversity. They should be kind of largely full of nice little critters. And within each farm, we sampled in multiple places. We looked at the location within a field, the field within a farm, the management of the farm, the region, and so on, whether it's in a hot spot and a cold spot. And I won't go into any of the details, but you can do quite complicated statistics these days and really tease out the effects of organic management or the management of your neighbours, whether you're in a hot spot or a cold spot and so on. Okay, so I'm going to show you some graphs. Now, you mustn't be frightened of these graphs. These are just, on the vertical axis, we have some measure of biodiversity, and on the horizontal axis, we have where those farms, where that data comes from. So to start off with, let's see if we can. These are plants. Okay, so these are just standard weedy plants in fields. This box here in red shows we have CH, that's cold spot, so intensive landscape. Hot spot is an organic landscape. Conventional farm, organic farm. What you find in the center of the field, on an arable field, you get a lot more biodiversity on organic farms than you do on conventional farms. Okay, that's what we expected to find. All well and good. So that's the center. Next block over is the edge of the field, then the margin, center edge, margin of a grass field, a pasture field. Similar sorts of effects, but smaller effects. When you get to the margin, there isn't really a strong effect of whether or not you're an organic or a conventional farm. And to all intents and purposes, most biodiversity on farms is found in the margins. This is an interesting thing. If you're a conventional farmer in a hot spot, so you've got quite a few organic farms in the neighbourhood, you tend to have more weeds in your crop. So you have a greater biodiversity of plants in your crop, simply because you've got neighbours who are organic. So that's a kind of landscape level effect, a neighbourhood effect. So that was plants. Now here we've got lots of other different groups. So we've got, that's the plants again. These are small wasps that do your natural enemy services, butterflies, hoverflies, bumblebees, and solitary bees. Lots of different patterns. So for some groups, so this is natural enemies, some groups, it makes no difference really whether you're organic or conventional. What really matters is where you are in the field. For other groups, this is hoverflies, which are a pollinator group. What you find is the opposite effect, in that on organic farms, you get fewer of them rather than more of them. And for some groups, like these are the solitary bees, which are an important pollinator group, what you find is that there is no clear pattern, but actually you get more bees in hotspots where there are lots of organic farms, and it doesn't really matter whether you're an organic or a conventional farm. What matters is the landscape in which you're in. So that's insects and plants and things like that. For birds, you get a different picture. I won't go into the details of this, but whichever way you measure it, you get fewer birds on our sample of farms, fewer birds on our organic farms than on our conventional farms. All right, now, we've done quite a lot of digging to find out why, because that's completely contrary to our expectations. And the reason that we're convinced of now, and I can show you a paper that we've just published to show this, is that on organic farms, typically they're nice farms for wildlife. And you get lots of birds. The trouble is those are the wrong sort of birds for conservation. So as Michael put up a graph, some of the birds that are going up are things like crows, magpies, jays, rooks, the corvids. And because largely these days farmers don't do predator control, what happens is that those birds end up frightening off the small birds. And it's not a direct that those big birds necessarily eat the small birds, but we did a study on yellowhammers. What happens is that the corvids stop the yellowhammers from foraging. They make the yellowhammers frightened, in effect, during the summer. And as a result, their chicks grow more slowly. And when they leave the nest, they're in worse condition, simply because they're frightened of their nest being nicked by a corvid when they leave it. So there are indirect effects that organic farming can be bad for the sorts of things that we care about from a conservation perspective, simply because there isn't proper pest control. This is butterfly data. I won't go into this in any detail because I'll talk a bit more about it in a minute. You get more butterflies in organic farms whether it's crop grass in the centre or the edge. But most importantly, when you compare the butterflies on farmland as opposed to butterflies on reserves in the same landscape, you always get far more butterflies on land that is set aside. One of the interesting things that came out of our study is that we had 190 odd fields, and we directly measured the yield from each field. And these are our distributions of yield for organic farms. This is winter wheat, largely winter wheat. There is some other winter cereal in here. This is organic farms' distribution of yield, conventional farms. When you look at the average, it doesn't really matter whether you're in a hot spot or a cold spot, organic farms produced about half the yield, 46% of the yield of the conventional farms. But because we've got variation, some fields were producing very high yields, even in the organic, some fields were very high yields, some fields